So this is for day 7, and for a cooldown called the Squirrel. This is actually going to be one of our more complicated ones. There's quite a bit of information here, so if you need to rewind, go back. Make sure you've got all of the stuff in this video in your notes. I mean, even if you think, hey, Mr. Van, I'm watching the video, why do I need to take notes? Because even just listening to what I'm saying and writing it down actually helps you learn it. So make sure that you do follow along, take some notes if there's anything missing from in class. Now, day 7, what was it even called? Day 7 was features of graphs. So the graph of the function can give us some useful information. So if we look at this, we have a height and a time. Now, keep in mind that this path right here, whatever thing that we're looking at, that's not necessarily what the path looked like. This is just measuring heights. It's possible that it started like at the top of a cliff and went straight up and then came straight down again. This is just tracking the height as time goes along. So if you're not sure what I mean by that, that's okay. But just keep in mind that this is not necessarily what the object actually did. This is just measuring the height over time. So the graph can give us some useful information. Some points and key features of a graph are particularly informative. So first of all, our vertical intercept. That is where it crosses the vertical axis or the y-axis. In this case, it's the h or the height axis. And what this tells us is that at some time, 0, when t is 0, the height of the object was 20. They're talking about a ball. So this point, the vertical intercept, tells us that the initial height, the starting height of the ball, is 20 meters, because when t is 0, the value of h of t is 20. We could also say that h of 0 equals 20. So what that's saying is that for my height function, which is a function of time, after 0 seconds, the object was 20 meters off the ground. Starting point. Second thing, highest point on the graph, also known as a maximum value. This right here tells me that after 1 second, it hit a height of 25 meters. And since that's the highest my graph goes, that is the maximum height the object reaches. So somebody threw this up in the air and then it came back down again. Probably off of like a building or a cliff or something like that. So the value of 25 is the maximum value of the function. It tells us the highest point is 25, and it gets there after 1 second. And we can say h of 1 equals 25 to represent all of that information. This right here by itself doesn't actually tell you it's a maximum, but what you could say is there's a maximum of 25 at t equals 1 or something like that. Next thing, horizontal intercept. This is where it hits the x or horizontal axis. If we're looking at height in meters over time, this right here is a time, 3.2 seconds, when the height is 0. Also known as when the ball hits the ground. It's the lowest point on the graph. It's a minimum. So after 3.2 seconds, the ball's height is 0. H of 3.2 equals 0 is how we can show it in function notation. And because h is not any lower than that, it's a minimum value. Number 5, height of the graph increases. So if we look at this, over the first second, my heights are getting bigger. And then the heights start to get smaller. So our object thrown up into the air came back down again. That maximum height that it reached was after 1 second, and then it started to fall. So the graph changes direction and the height decreases when t is between 1 and 3.2. Neither the increasing part nor the decreasing part is a straight line. Those are curved. And this is what you typically see when you're dealing with gravity. Now, when it hits the ground over here, it's perfectly flat. It's not increasing or decreasing. So we would say it's a constant rate. Height does not increase or decrease. I think that's about it. So increasing, decreasing, constant. All right, last thing. This is just talking about intercepts. Intercepts are always fairly easy to deal with. When you have a vertical intercept, the x value is always 0, and the y value is always your starting value. Horizontal intercepts, that's always where your y or your vertical axis is 0, and that'll tell you where that is. And if this right here, 0, 0, tells you that crosses through the origin. So what you need to do in this cooldown, we have a squirrel running up and down a tree. Here's the graph that shows the squirrel's height over time. What is the highest point the squirrel reaches? H of t equals 0. Where is my height equal to 0? At what time? Remember, a solution is a number or numbers that replace a variable or variables to make an equation true. So h of what equals 0? You're going to give your answer as t equals some number. Find the vertical intercept of the graph. Vertical axis. What does it tell you about the squirrel? If you have any questions about this, let me know.